Welcome to the second part of the series, What is 3D printing and how it works. What's up guys, I am Sandeep and you are watching Duval. If you are new to this series, the first video was all about what is 3D printing, how it works, importance and its benefits. This video is all about the types of 3D printing processes. Types of 3D printing processes. The American Society for Testing and Materials developed a set of standards that classify additive manufacturing processes into 7 categories. VAT photopolymerization. A 3D printer based on the VAT photopolymerization method has a container filled with the photopolymer resin. The resin is hardened with a UV light source. Material jetting. In this process, material is applied in droplets through a small diameter nozzle, similar to the way a common inkjet paper printer works. But it is applied layer by layer to build a platform and then hardened by UV light. Binder jetting. With binder jetting, two materials are used, powder-based material and a liquid binder. In the build chamber, powder is spread in equal layers and binder is applied through jet nozzles that glue the powder particles in the required shape. After the print is finished, the remaining powder is cleaned off, when often can be reused printing the next object. Material extrusion. It works using a plastic filament which is unwounded from a spool and is supplied to the extrusion nozzle, which can be turned the flow on and off. The nozzle is heated to melt the material and can be moved in both horizontal and vertical directions by a numerically controlled mechanism. The object is produced by extruding melted material to form the layers as the material hardens immediately after extrusion from the nozzle. Powder bed fusion. It uses a high-power laser to fuse small particles of powder into a mass that has the desired three-dimensional shape. The laser selectively fuses powder by first scanning the cross-section on the surface of the powder bed. After each cross-section is scanned, the powder bed is lowered by one layer thickness. Then, a new layer of the material is applied on the top, and the process is repeated until the object is completed. Sheet lamination. Sheet lamination involves material in the sheets which is bound together with the external force. Sheets can be metal, paper or form of polymer. Metal sheets are welded together by ultrasonic welding in layers and then CNC milled into a proper shape. Paper sheets can be used also, but they are glued by adhesive glue and cut in shape by precise blades. Directed energy deposition. This process is mostly used in the metal industry and is a rapid manufacturing application. The 3D printing apparatus is usually attached to a multi-axis robotic arm and consists of a nozzle that deposits metal powder or wire on a surface and an energy source that melts it, forming a solid object. Industrial applications of 3D printing. Aerospace and defense. The aerospace and defense industry is one of the earliest adopters of 3D printing, with the first use of the technology going back to 1989. Using the technology, complex geometries can be created without having to invest in expensive tooling equipment. This offers aerospace OEMs and suppliers a cost-effective way to produce small batches of parts cost-effectively. Reducing the weight of an aircraft can significantly reduce its carbon dioxide emissions, fuel consumption, and payload. This is where 3D printings come in. The technology is an ideal solution for creating lightweight parts, resulting in considerable fuel savings. Automotive. While prototyping currently remains the main application of 3D printing in the automotive industry, companies are increasingly finding other use cases, such as tooling. 3D printing offers automakers a cost-effective and flexible way to produce customized parts. Within the luxury and motorsports segment of the industry, companies are already using the technology to produce personalized parts for both the interior and exterior parts of the vehicle. Medical and dental. 3D printing is ideal technology for creating or optimizing designs for medical devices. The medical industry can leverage the capabilities of 3D printing to create patient-specific devices. Consumer goods. To remain competitive in an ever-changing market landscape, retailers and consumer-oriented industries must be able to adapt to evolving consumer demands and industrial trends in an agile way. Additive manufacturing meets these needs, providing a cost-effective approach to product development, testing, and production. From consumer electronics to toys and sportswear, key players within the consumer goods industry are increasingly recognizing 3D printing as a valuable addition to existing manufacturing solutions. Industrial goods. The industrial goods sector includes the production of machinery components, tooling, and equipment used in the manufacture of other goods. With increasing production costs and digitization of manufacturing, industrial OEMs must constantly evolve to maintain operational agility and keep costs down. Since 3D printing can produce physical parts from digital files in a matter of hours, companies can leverage a new model of manufacturing parts on demand. Future of 3D printing. A variety of 3D printers for homes and small businesses is readily available, but they are still often viewed as exotic and rather pricey. Expect that to change within the next few years, when 3D printers will become more commonplace in houses to be found on workbenches, in studios, in home offices, and even in the kitchen. You may not find them in every household, but they will become indispensable to those who do have them. For the most part, items made with 3D printers have had homogeneous interiors, but we will start to see more complex creations combining multiple materials and composites, as well as printable electronics. Also, 3D printing is gaining a foothold in outer space. NASA is experimenting with 3D printers on board the International Space Station. Eventually, 3D printers could be used to create habitats on Mars and other worlds. Likewise, we will see 3D printers in Antarctic bases and other remote earthly locations, where people can't wait 6 months for the next resupply to replace essential parts or tools. The past few years, we have seen an explosion in the variety and uses of 3D printers. Though it's easy enough to see some of the areas the field of 3D printing will branch into, others are beyond our ability to predict. Just as no one around in 1980 could have imagined much what about personal computer would turn into, it's possible that 3D printing may not have the same impact as the PC on consumer, everyday life level, but it does have the potential to revolutionize manufacturing and perhaps more important, to bring it into the hands of everyday consumers. But one thing is sure, the 3D printing is here to stay. If you really enjoyed this video, make sure to subscribe to my YouTube channel right now. Just click the button below this video.